Hello everyone. In this video, we are going to see microphones and its types. Now, we will see how does a microphone work, the basics of the microphone. Microphone are a type of transducer, that is, a device which converts one form of energy into the other form. That is, microphone converts the sound wave into electrical energy, that is the audio signal. So this is the diagram which shows the sound waves comes and hits the microphone, and the diaphragm which is there inside the microphone which converts the sound wave into the audio signal. Next, we'll see the types of microphone, that is dynamic microphone, condenser microphone and ribbon microphone. Now we'll elaborately see about the dynamic microphone. So the working process of a dynamic microphone is it works on an electromechanical induction. That is, this type of microphone is also called moving coil microphone. A very small coil which is attached to the diaphragm, which is suspended in the magnetic field. That is, when the sound waves comes and hits the diaphragm vibrates, so that the coil which is attached to the diaphragm also moves. This movement of the coil inside the magnetic field produce electromagnetic field across the terminals of the coil. So the current it is produced in the coil, it is proportion to the sound. So this is the diagram of a working process of a dynamic microphone. You can see the sound waves comes and hits the diaphragm. The diaphragm is attached to a coil and the coil is suspended in the magnet. Okay, a magnet is there. So around the magnetic field is there. So when the sound waves comes and hits the diaphragm, automatically the coil which is attached to the diaphragm vibrates. So the coil is vibrating in the magnetic field, so that it converts the sound energy, that is audio, into the electrical signal. Okay, so this is the working process of a dynamic microphone. Next, we are going to see about condenser microphone. Condenser microphone is called as capacitor microphone or electrostatic microphone. It is made up of two parallel very thin plates. It is positively and negatively charged. A condenser microphone uses a pair of charged metal plates. One is fixed, that is called backplate. Another one is movable, that is called diaphragm. It is also forming a capacitor. So when the sound waves comes and hits the diaphragm, the distance between two plates changes, which produces a change in the electrical characteristic, that is called capacitance. It is the variation of spacing due to the motion of the diaphragm relative to fixed backplate, which produces the electrical signal that is corresponding to the sound pickup. To obtain a signal, condenser microphone require an electrical current to charge the plates. The current is usually provided either by a battery or it is sent down to the microphone cable itself. This latter method is known as Pantheon powering. Most of the condenser microphones can operate with Pantheon power, that is voltage ranges from 11 to 52 volts. Now we are going to see about ribbon microphone. A ribbon microphone uses a corrugated ribbon made up of a metal that is suspended in the magnetic field. The sound causes the ribbon to vibrate. This means change in the magnetic flux through the ribbon. This induces an electrical current which drives the speaker. When this current is flown through the coil that is attached to the diaphragm of the microphone, the diaphragm vibrates and produces the sound. The special material is developed using the nanotechnology that is being used to make the ribbon that will be light but strong. Being light improves the response of the sound. The ribbon microphone senses the pressure gradient and not just the pressure. Therefore, it detects the sound from both the sides. So this is the diagrammatic form of a ribbon microphone. You can see the ribbon inside and it is suspended in the magnetic field. You can see the ribbon is attached to the output. So when the sound comes and hits the ribbon, automatically it is suspended in the magnetic field. So the sound wave is converted into an electrical signal. Thank you. We will see in the next video.